Unit 11, Lesson 1. In this video, I'm going to cover how to correctly answer problem 2 and 4 from the homework. The directions say to identify the 6 trigonometric functions for number 2 and number 4. It also tells us not to rely on drawing a triangle, but to use the trigonometric identities. And here are the trigonometric identities. We went over in lesson 1 how to come up with this initial one. And if you can understand how to or memorize that sine squared theta plus cosine squared theta equals 1, these are just a variation. It's equivalent variation. As a quick reminder, if I divided each of these by sine squared, so sine squared divided by sine squared, I'd end up with 1. Cosine squared divided by sine squared is cotangent squared, and 1 divided by sine squared is cosecant squared. Now I could achieve the second equation, which is just a variation of the first, by taking each one of these original terms and divided by cosine squared. Sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is equivalent to secant squared. So they're all variations of this first trigonometric identity. Where do we get started here? Well, I'm going to go find where it says cosecant, and I'm going to write -2 or -2/1. That means the sign must be the reciprocal. Same sign, just the reciprocal of the value. This is a fancy way of saying that the tangent values are positive. I know tangents are positive in quadrants 1 and also in quadrant 3. So how do I decide where does this land? Well, if the sine value is negative, it means it must land in quadrant number 3. And in quadrant 3, only tangents are positive. How can we use our trig identities to now find the missing values here? Well, I know the cosecant is equal to -1, so I'm going to write down this last identity. 1 plus cotangent squared theta equals cosecant squared theta. And in place, I'm going to put a -2. And it's squared. Okay, now let's isolate the cotangent squared. -2 times -2 is 4. I'm going to subtract 1 to the opposite side. Cotangent squared theta equals 3. Taking the square root, I have the cotangent of theta is equal to +3. Because I know it's representing a ratio of 2 of the 3 sides of a right triangle, these are lengths, and it only will ever be a positive value. We don't put a plus or minus as if we were just solving an algebraic equation. So I'm going to come up here to cotangent, and we have the square root of 3/1, and now this will be 1 over the square root of 3. Not wrong mathematically, but it's not in proper form. Let's write it in proper form. Proper form will be 1 square root of 3/3. How can we now figure out what the cosine and the sine are? Well, there's a couple different ways that we can do it. I would say one of the most common is that we could come up here and we could put more numbers into these identities. More than one way to go about doing this. I know I am now seeking to find the cosine and the secant. So I look up above. Okay, cosine's in the first version of the trig identity and secant's in the second. It's up to us on which one we want to use. I think I'm going to choose to use the first equation. So sine squared theta plus cosine squared theta equals 1. I know that the sine is -1/2. Now I'm going to isolate the cosine squared, which means I'm going to leave 1 on the right-hand side, and then I need to take this quantity. I'm going to come off to the side. Notice that -1/2 times -1/2, 2 negatives make a positive. 1 times 1 is 1. 2 times 2 is 4. So I really have a positive 1/4 on the right. When it moves to, on the left, I have a positive 1/4 in this position. To move it to the right-hand side, I have to do the opposite operation. So I need to subtract a 1/4 to both the left and right. We could use a butterfly method. You could use common denominators. I think I'll do common denominators here. Times 4 times 4. I know 4/4 is the same as 1. 4 minus 1 is 3, so I have 3/4. And now I want to isolate the cosine. I want simply cosine, not cosine squared. So I take the square root of both. That means the square root of 3 over the square root of 4. Now the square root of 3 is an irrational number. Can't be simplified, but the square root of 4 is 2. So up here I get to go square root of 3 over 2. The reciprocal would be negative 2 over the square root of 3. Not mathematically wrong, but not in proper form. So negative 2 square roots of 3 over 3. Let's look at number 4. Number 4, and I'm actually going to take my paper right now and I'm going to fold it so we have a better chance of seeing the identities and deciding which one is most advantageous to use. The tangent of x is equal to negative 3. Same directions apply. So negative 3 over 1 and negative 1/3. Okay, where are tangents negative? They're negative in quadrant 2 and in quadrant 4. This says the cosecant. Well, that's a reciprocal of sine. So if the cosecant is less than 0, it's a fancy way of saying the cosecant is negative. If the cosecant is negative, it means its reciprocal sine is negative. Which one of these two locations has sine values that are negative? That would be quadrant 4. So in quadrant 4, only the cosines are positive. I'm going to start by putting a plus sign in the cosine and its reciprocal and a negative in the other locations. Where do I get started here? Well, I see tangent, so I look up above and I'm like, I think I'm going to go and use the second equation. 1 plus tangent squared theta equals secant squared theta. So I'm going to place into this position a negative 3 or negative 3 over 1 to square it. 1 plus negative 3 times negative 3 is positive 9. 10 equals the secant squared theta. We take the square root, and then we ask ourselves, is it possible to break down and reduce the square root of 10? So what perfect squares divide nicely into 10? 1 does, but it doesn't help us reduce. 4 does not divide nicely into 10, and 9 does not divide nicely into 10. So I feel confident that the secant is the square root of 10. Square root of 10. So this would be 1 over the square root of 10. Not mathematically wrong, but not in proper form. So 1 times the square root of 10 over 10. I'm now looking to find the values of sine and its reciprocal. So I have two choices. I could use the first equation because it has sine, or I could use the last equation because it has cosecant. There's not a wrong way of going about doing it. In my mind, I'm like, what looks easier? So if I use cosecant, then I would have to know what cotangent is. Okay, cotangent's a fraction. If I go with the equation that has sine, I need to know what cosine is, and cosine also is a fraction, and it also has a square root in it. There's no easy answer here. I think I'm going to stick with this last one. So 1 plus cotangent squared theta equals cosecant squared theta. If you use the same equation, I can prove how we're going to get the exact same answer in the end. Let's put in what we know. We know that cotangent is negative 1/3. We need to square it. Negative 1/3 times negative 1/3. Well, let me write that out. Negative times negative is a positive. 1 times 1 is 1, and 3 times 3 is 9. So I need to add 1 plus 1/9. I think the easiest way to turn into a common denominator is making that 1 into a 9 over 9. 9 over 9 is equivalent to 1. Now I have 10 over 9 equals the cosecant squared theta. Taking the square root, I have the square root of 10 over the square root of 9. The square root of 10 cannot be reduced, but the square root of 9 is 3. So I'm going to come up here and place this is going to be negative square root of 10 over 3. In this position, we're going to take the reciprocal. So 3 over the square root of 10. Not mathematically wrong, but not proper. So negative 3 square roots of 10 over 10. Now let me prove to you, using the small space down below, if you would have said, you know what, I prefer to use that first equation, how can I still achieve the same answer? So I need to put, in order to figure out what the sine is, I would have had to plug in this value for the cosine. And I could have done either the first one or the second one. Let's try the first one, actually. They're equivalent forms. So let's put in 1 over the square root of 10. And now I have to square it, so I'm going to write it down twice. So sine squared theta equals 1 times 1 is 1. The square root of 10 times the square root of 10 is going to be the square root of 100. I know 1 over the square root of 100 is really going to be 1 over 10. And now I need to isolate sine squared. So sine squared theta, I'm going to take this positive 1/10 and move it to the other side by subtracting. And I need a common denominator, and a good common denominator would be 10, so I can transfer 1 into 10 over 10. I ended up with 9 over 10. I take the square root of both, and now I have the square root of 9 over the square root of 10. So let me write that down, square root of 9 over the square root of 10. That's what sine is equal to. Well, this is equivalent to 3 over the square root of 10. Now, it's not in proper form, but we could quickly put it into proper form by going 3 square roots of 10 over 10. And look, that's exactly what I got here. You may be saying, but yours has a negative sign. Remember, we determined the values, or excuse me, the sign values based on what we were given. We were given that the tangent has to be negative, and also that the sine is negative, so we knew it landed in quadrant 4. That's what determined negatives for sine and its reciprocal, and negatives for tangent and its reciprocal.